Hello, 10 of us, okay. I don't know, guys, should I worry about low attendance or not? People watching this on their own time, I hope. By the way, thank you for the feedback that y'all gave the other week. The most negative thing in many classes that were online was this lack of student interaction. And quite frankly, I don't know how to fix that in a class like this, other than, go to the Discord, go on the discussion pages. If you're on campus, find people to meet with. I think we put up a place for a discussion page for people that wanted to study together that you can advertise for study groups. We can try to get some student interaction that way. Okay, we are here on February 22nd. We're going to talk about inheritance, polymorphism, and design. And your P2 is due tonight, and homework 3 was extended, so it's also due tonight. I think people have homework 3 under control now, based on the feedback I'm getting online, or the lack of panicking that I'm getting through Canvas messaging. Okay, let's go through and talk about some design type stuff. Primarily, let's talk about overloading and polymorphism. As always, at the end of the week, please go look at these and explain each one to a friend or a stranger. I don't care. Just explain it to somebody, so that that's the best way to know that you understand something, is to explain it. Okay, we talked last week about relationships between classes, the HAZA, which is where one class contains another. So you can build complex objects by having them composed of other smaller objects. And then we have this is a relationship, which is the inheritance. That's where we're going to do our focus on this lecture. Everything else we're going to call association for this class. There are other specific forms of relationships. We're not going to worry about it. HAZA, ISA, if it's not a HAZA and it's ISA, but these two classes know about each other, or this class can't do its job without some information from that class, then we're going to call that association. Okay, and before we talk specifically about the HAZA, or the inheritance relationship, we're going to talk about overloading, because then I'm going to contrast that with what we get with the inheritance relationship, which is more properly called polymorphism. So overloading. Overloading is when you have multiple versions of the same method, but they differ in their signatures. What's a signature? Go to my friend Notepad here. Here's the signature right there. It's the return type, the name of the method, and the input parameter list based on their data types. So this thing takes in two integers and it spits out nothing. It spits out void, right? It returns nothing. Okay. If I have in the same class two methods with the exact same signature, what problems does that bring up? How is that not, that is not allowed. Why is that not allowed?
Is it because they're the same and that can overlap in like calling them?
Right. So when I call them, remember what you're doing. When you're calling a method, you're telling the Java virtual machine to go run that method. And the Java virtual machine looks in this class and says, wait a minute, I got two of the exact same thing. I don't know which one of these you want me to do. So we can fix that. I'm going to fix it first by doing that, by changing the Y to a Z. Did that really fix it or not?
I don't think so, because
why?
the signature is still the same.
Right, some other class. If I said, oh gosh, let's do it properly. Object 1 equals new B, right? And then I say object 1 dot foo 0, 0. Can you tell by looking at that? I called foo 0, 0, so foo has an, I'm calling foo down here with an integer and an integer. Can you go back up to the class B definition as a human and figure out which of those two versions of foo I wanted?
No.
No, no. And if you can't, you better believe the Java virtual machine can't. So it's not just about the name of the variable, it's the data type. But what you are allowed to do is this. I can add another variable. Now go back down here, foo with 2 integers as input. Now can you go back to B and unambiguously decide which version of foo I want you to do?
Yes, you can.
Yeah, it's that top one. And you can do this trick. And if I call object 1 dot foo 0 1.0, that second version of foo down here, can you go back to B and unambiguously decide which version of foo I wanted from class B?
Yes.
Yes, you can.
Yes, because I have an integer and a double, and there's only one of those that does that. And you can also change anything that you change in the signature is fine. Okay, now I'm calling object 1 foo again with 2 integer values. Which of these foos are going to be the one that I'm asking for here? How can you tell? That's tricky, right? Because I got 2 of them that require integers, 2 integers as input, so it's a little trickier.
Because in the signature it's an integer, and in the other signature it's void, and I think void means that it's not going to return.
Right, void means it's not going to return anything, right? And clearly when I say result equals whatever I got back from this method, I'm saying that I need an integer value here because result was defined as an integer. So if I say result equals, whatever's on the right-hand side of that equal sign, it better be an integer. So object 1.foo 0, 0 has to give me back an integer. And there's only one version of foo in class B that takes in 2 integer values and returns an integer. So again, it's unambiguous.
So, Professor.
Yeah.
What if you had 2 classes that called 2 integers? Which one would it pick then? Or would you ever have that, I guess, really?
2 classes that call to, give me an example. Here,
I don't know, like let's say that you just had 2 of these in a row with 2 different integers. I guess it would override it, wouldn't it? If you had 0, 0 and like 5, 5, you know?
Oh, yeah, yeah. So yeah, if I did this, like that?
Yeah.
Yeah, that's fine. Because what I'm saying is first run foo with 0, 0, and now run foo again with 5, 5.
Okay.
But
okay,
in both
cool.
cases, in both individual cases, the Java virtual machine knows exactly which version of foo I want to run.
Awesome. Thank you.
Okay.
Yep.
Now, what if I did this? And I say here, I'm going to change that to object 2. Now, which version of foo gets activated now? Which one gets executed?
The one in the C class.
The one in the C class, right? So again, you now, even though foo here, void foo int int and void foo int int are the same in the B class and the C class, that's okay because they're separate classes. That's just fine. Because when I declare the objects, I'm going to declare them either as an object of class B or an object of class C. And either way, the Java virtual machine knows what to do. So in this first line, I say object1.foo. I say, okay, object1 is of class B, and I'm telling the Java virtual machine, if you look inside object1, you're going to find a method called foo that takes 2 integer values as input and doesn't give anything back. And sure enough, that first definition meets that. So the Java virtual machine can go find that. And then we have this, which is, okay, now I would need you to go to object2, and inside object2 is a method called foo that takes 2 integers as input and doesn't give you any output. Oh, and by the way, object2 is of class C. So it goes and looks inside class C. Sure enough, there's the method foo, and it unambiguously can determine what you want done. If these two methods show up in different classes like that, that's not overloading. The overloading is what I'm doing here, where it's all in the same class. You are allowed to have, let me get rid of this extraneous junk here. You are allowed to have something like this, where you say class B has foo with 2 integers, class C has foo with 2, right? It's the exact same signature. You're allowed to do that. Now, here's my question. Is that a good idea or a bad idea?
I would say bad idea, because I feel like at a certain point, if you're trying to like debug it, you can often misread it because they have the same method.
Okay. So we have an opportunity for confusion. Is this true?
Yes.
I mean, that's basically what you're saying, right? It can be confusing. So
Yeah, because
sir, it
in
is.
your example, it's all like very close together, but in a like maybe a 75 line program, it might not, and you might assume like
Well,
object2.foo
okay.
is still in B object1.
Right. And let's go to a 75,000 line program. Yeah. Okay. So here's the rule. There's no rule. It's a bad idea if there's no reason to do it and it causes confusion. However, let's say those methods, remember, I keep telling you guys, name the method what it does. If that's the job of the method, name it what it does. What if you really have a method that's doing basically the same thing in 2 different classes? Is it okay to name them the same thing? In that case, I would say yes, because there's no reason to, you got a great name for this method, like the move method. Right, you need something moved. Let's call it the move method. And now in another class, I need the move method again. I don't want to artificially change its name just to avoid an arbitrary rule. If it really is the best description of what's happening, do it. And again, name your things, name your methods what they are. And remember, in object-oriented world, what we really want, we want methods that do one very small specific job. Your methods, if you've got 10 lines of code in a method, you might want to look at that method and say, gosh, I wonder if I can break it up. It might be trying to do too much work. So these are very small specific jobs. And if that small specific job is the same across different classes, that is okay to name them the same thing. These are design choices. It has nothing to do with the legality of Java or, will it compile, will it not compile? It's all about design choices. So if you think that, okay, because of the clarity of what the method is doing, it deserves the same name, by all means do it. In fact, there may be some code understanding there if you find that the same behavior has the same name throughout all the different classes that do that behavior, that actually may be helpful. Now, the contrary to that is exactly what you guys were saying. We can always get confused. I'm particularly good at it. Okay, so that's overloading. This is different. This is different than I'm going to change these. This is different than polymorphism and inheritance. And so let me change these guys. Yeah, da, 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 da. There we go. Okay, let's do public class A, and it returns, I'm going to put a 0 here just so we can differentiate it, and public class B extends A, and public class C extends A. Okay. Now what's happened? Now we've got an inheritance relationship. This is the is a relationship. Public class A is the generic form of the class. And then B and C are the more specific forms. So again, in our sheep-dog game, A might be the generic animal, and then we extended it to dog and sheep, so that, you know, so B might be the dog and C might be the sheep. Obviously, we would name them appropriately. Or in the ship example I keep bringing up, the generic ship would be class A, and then B extends it to, I don't know, tugboats, and C extends it to rowboats, I don't know. So we have an is a relationship. The is a relationship is not about overloading. Remember, overloading occurs all in the same class. The is a relationship is called polymorphism. And the reason it's called polymorphism is this. Remember, polymorphism is literally means many shapes or many forms. That's the literal definition of the word. And so here I have foo returns 0, and in B I have foo returns 1, and in C I have foo returns 2. The signatures are exactly the same, but the behaviors are different. Now, how did I make the behaviors different? I made the code inside the method different. That's where the polymorphism shows up. The same method has different forms, different code inside the different classes.
So you're saying that typically the inputs will be the same, but the code inside of the class will be different?
In an inheritance situation with polymorphism, yes. Otherwise, it's overloading again. If we change the signature, we're back to overloading. But if we keep the signature, we are allowed in the child class to modify the methods that showed up in the parent class. So A is the parent and it returns 0. And then when I do class B extends A, I am allowed to take any method I want to and modify it. And not only am I allowed to, my argument to you guys is when I keep telling you, okay, I don't think you have a good case for inheritance, and here's why I don't think you have a good case for inheritance, you didn't have to change any methods. If you don't have to change any methods, you don't need inheritance. The inheritance is about children that behave differently. How do you get different behavior? The methods behave differently. How do you get methods to behave differently? You actually have different lines of code inside the method. Does that make sense? So there's a lot of, initially when people come across inheritance, they get confusion because they present, oh, this class is clearly different than that class, but it's really attribute values. It's not behavior. So for example, I think we talked about this example last week or the week before. If I have your basic Cessna 172 and your basic jet trainer, you know, what's the latest jet trainers? T whatever, right? They seem like they behave really differently. But it may not be that we would need new classes for them because the behaviors may be attribute values. Max speed, attribute value. Max altitude, attribute value. Landing speed, stall speed, angle of attack, attribute values. Now,
Okay, I think this helps me a lot for my project. I'm finally
Good.
understanding the
Oh.
difference.
I'm pleased that I'm helping and not hurting. Right, so that's the thing. Now you may find that there are differences that are so behaviorally unique that you cannot describe them with attribute values. let's take the trainer and replace it with a fighter, which has missiles and bombs and radar and stuff like that. Well, that plane literally has different behavior, like shooting things or having radar to determine where other entities are, that the Cessna doesn't have. No, maybe we could argue ADS-B is doing that job now. I don't know. Right? That's a real behavioral difference. And the same thing with, let's say you have a commercial airliner. Well, this whole thing where you're loading on and off hundreds of passengers, that may be enough of a behavioral difference that you're not just going to have an attribute value difference between the Cessna and the Boeing 777, which I hear they've grounded now that that engine caught on fire. Okay, so this is about behavioral differences. Now, let me do this trick. I'm going to do this. And I'm going to ask the same, I don't need that guy anymore. And I'm going to ask the same question. So my first question is, am I allowed to do this? Am I allowed to say A object 1 equals new B? Am I allowed to do that?
I don't think so.
You don't think so? Okay. It looks weird, doesn't it? It looks wrong because I'm saying that object 1 is of class A and then I'm building it of a class B. But what's my other word for the inheritance relationship? Is a. It's not an accident. Is a. Oh, wait. Class B extends class A. In other words, B is a A. So I say A object 1 equals new B. That's actually okay because B is a A. Go back to our ship example. Cruise ship is a ship, is it not?
So A would be the ship in this example, and B would be like the cruise liner.
Exactly. A is the generic, right? And the generic one is always the parent, right? So we have the A is the parent, B is the child, and you always have a generic parent, and then you have children that are more specific to a specific job.
Is it possible when you're writing code that you would make the ship class, and then when you're making the children of the ship, you would never actually even code a generic ship? You would just use all of the children?
That absolutely is true, yes. And we'll talk about that later on in the course that, you may realize that's called abstract. Yeah, so you can have abstract classes, but we don't need to deal with that now. But yes, it's absolutely possible, and it's probably good design to not even code certain aspects of the parent, other than providing the attributes and the method signatures that you need. So you could have the attributes and the methods and the parent, but when you're using inheritance properly, you never, ever, ever create an object of the parent class, because none of you, like, think about automobiles. How many of you guys have a truly generic automobile that you drive around? I mean, that's a nonsensical question, right? You don't ever have a generic thing. You have a specific brand of automobile. You have a specific type of ship, a specific type of aircraft with these objects that are actually built. Nobody has some of us have dogs that are mutts, and are proud of it, but nobody has a generic dog. It's just, what kind of dog is that? It's just generic dog. There is no such category in the
Professor.
rule. Yeah.
So, but what if, yeah, sure, you drive a Volkswagen, right?
Yeah.
But you also can drive a generic like sedan or an SUV, right? It's still a car, but sedan
Sure,
or SUV is super generic too.
And the Volkswagen is also generic, but if you said to me, I drive a sedan, I could say what type, what make and model, and you can't stop it. And you didn't buy, right? If you look at your registration, I guarantee you it say generic sedan, right? It may say sedan, but it also says make and model.
Yeah. Okay.
Okay. Yeah. You still belong to the superclass, and that's the is a relationship. I have a Dodge Journey. It's an SUV, right? A Dodge Journey is a SUV. So if you ask me, what do I drive? I'd say an SUV, but then you wouldn't stop there because obviously I don't have a generic SUV. You would say, oh, what kind?
So, Professor, does
Yeah.
does that word between B and A and C and A extends? Does that
Yes.
actually do? What does that do in Java exactly?
That is how you tell the Java compiler that class B is an extension of class A, that it's a child of class A. So it is a version of class A. And what's going to happen when the thing is compiled, all the attributes and the methods that are in A, class B gets automatically. They inherit them automatically. And then if you want to modify the methods, you're free to do so.
Oh, so you're saying if you would type up public class A, and then you would say public enter foo, and then you would write in a bunch of codes for the method, and then you could just write public class B extends A, and you really wouldn't have to do any more coding because the only thing that would change would be the inputs.
Right. So like here I have now class A has 4 attributes, X, Y, Z, and D. And class B, how many attributes does it have?
It would have 4 as well.
X, Y, Z, and D, even though I didn't do anything. And if I did this, how many methods does class B have? It still has the foo method that returns 0. Now, why
Okay,
would you do this?
it's starting to click.
Okay, good, good. Now, why would you do this? You wouldn't do it where the extended class is completely empty. The main reason you're going to do this is because you need behavioral difference. So that means that you're going to take the extended class, in this case, class B, and you're going to modify the code in at least one method from class A. At least one. And probably more than one. But class A, let's say class A has 10 methods. How many are you going to change in class B in a real situation? Probably 2 or 3. Some of them are going to be okay. Now let's go through what the Java virtual machine is trying to do here. If I said here, A object 1 equals new B, what I'm saying is, first of all, the Java machine is going to look at that and say, oh, wait a minute, you said it was of type A, and now you want me to build a B, so I'm going to go look at B, and it says, okay, B extends A. So the Java virtual machine says, okay, you're fine. I'm going to build you an object of class B. But remember, an object of class B is a A, right? It's also an A. And now down here I say, I made those integer values, so let me put a thing in there. Okay, now I say, okay, now I need you to go run object1.foo. And what I'm saying is, hey, if you go look in object1, you're going to see a method called foo, and I need you to run that method. And I'm going to do it first. Let me do this. I'm sorry, I'm going to do it out of order. Let's do it down here. If you go look in object2, you're going to find a method called foo. I need you to run that method with 5 and 5 as input. So the Java virtual machine goes up to object2, which is of class C, and looks in there, and sure enough, there's an object of a method called foo that takes 2 integer value inputs, and it returns an integer. Everything's great. It runs the method. Now, obviously, this is a description of the behavior. How does that all get managed in memory to make work? Far more complicated to the course, but logically, that's how you should think of what's happening. When you say object2.foo55, you really are saying, hey, go look inside that object. There should be a method called foo, and I need you to run that method. And so Java virtual machine will go look inside that class, find that method, and run the method. Now let's do object1. I made a promise to the machine, didn't I? I said, hey, if you go look inside object1, you're going to find a method called foo that takes 2 integers as input. I need you to run that thing with 0, 0 as the input. And the Java virtual machine looks inside class B, and what does it find? Or what does it not find?
There's no method.
There's no foo, right? There's no foo. But it also says B extends A. So now the Java virtual machine will say, oh, I can't find foo here in class B, but I see you're an extension of A. So I'm going to go up to A and see if I can find it there.
So it would return the 0.
It would return to 0, correct. And if you have, you know, parent, child, parent, child, parent, child, it keeps going up and up and up and up and up the chain until it finds something. For example, all of you have at this point created objects and you've used the constructor for the object, right? You built a projectile object in this last homework, but you may not have built the actual constructor for the projectile, right? You did the projectile class, and then when you wanted to build a projectile in the manager class, you built a projectile object, and you said, you know, projectile hair equals new projectile, parentheses. You were calling a constructor object for the projectile. And yet you didn't actually write that constructor code. So how did you get a constructor that you didn't write? Java, all objects are automatically children of other objects. So the Java language takes care of you that automatically. Good news and bad news, right? The good news is you didn't have to worry about it. The bad news is they're not telling you about it, so it's hard to understand what's happening sometimes. Now, if I put this line of code back in and I rerun this object1 foo 00, now what happens? I'm telling the Java virtual machine, hey, you go look on object1, you're going to find a method called foo 00 that takes 2 integer values as input. Please run that. And sure enough, we go in here to class B, and there it is. And so it'll return 1. You see how small this code is. You can write code like this, and I recommend doing it just so you get a better feel for how these things work. You can write code and play around with these objects, you know, that do stupid simple things like this: return 1, return 2, print out a system message that's informative based on what you're trying to learn. It doesn't take that long, and it's worth the time to play around doing these simple objects just so you understand how to create them and how the inheritance mechanism works. Now, I started off this discussion talking about polymorphism versus overloading. Overloading, again, is when you have in one class multiple versions of the same method, but it has different signatures. There's not usually many opportunities for that. However, you can actually build your own constructor functions, and we'll talk about that next week. And you may have multiple versions of constructors, but sometimes that's where I tend to use it the most, is multiple versions of constructors. But sometimes you have different inputs that you want to feed to a method at different times, so you can use the overloading. What you're primarily going to use here is this polymorphism. And why do I call it polymorphism again? Well, look at, here's class A. It's got foo with the same with a signature of int, the name of foo, and then 2 integers as input. And it's returning 0. And this one in class B, it has the exact same signature, but I have different code in here. Now, clearly this is the simplest different code I can have. In general, you're going to have 3, 4, 5 lines of code, and they're going to be different from class A to class B. And they're also going to be different in class C. That's the polymorphism, multiple forms, multiple shapes. You have multiple forms of the body of the methods inside the different classes. And again, why are you doing that? You're getting different behavior out of the classes. That's where you want inheritance. Things that are very similar in terms of their attributes, but behave differently. Sheep versus dogs. We said, gosh, they have the same attribute, but their movement behavior is different. So I have the generic animal with all the attributes and a blank move method. And then when I go down to the sheep and the dog, we inherit all the attributes. We inherit the move method too, but we'll change it for the sheep and we'll change it for the dog. The dog responds to user input. The sheep always run away from the dog. Okay, so there's a drill down difference, and we'll talk more on this on Wednesday with the code examples that I had from last week. Let me see. Is there something else I need to do here before I might forget and come back to it? Yes, one more thing. This is not just a cheap trick. Huge, huge, powerful tool in object-oriented design. For example, in some other class, I'm just going to call it, that's fine. Okay, so I've got this method in this class, and it takes in, now what's its signature?
Public double compare.
Right, so its signature is it takes a double, as a return type of double, its name is compare, and it requires as input 2 objects of class A. That's its.
Will the fact that class A is an integer affect the double?
A is not an integer. Class A is not an integer. Class A is a class. The class itself is its own data type. Inside of class A, we have 4 integer attributes. And inside of class A, we have a method that returns an integer, but class A is all of those things. It's its own data type composed of all of those things. You're awfully quiet.
Oh, sorry, I was just listening.
So yeah, that is the actual data type. A is the data type. So what I'm saying here is this thing is going to return a double. Its name is compare, and it's going to do something. But what does it need as input? It needs 2, just like the foo on top needed 2 integers. This needs 2 objects of class A. So clearly, let me change some stuff here. If I did this trick, and I wanted to call this thing compare object 1, object 2, would that work? Does that match the signature?
I believe it would. It would just be comparing 2 zeros, though, correct?
No. Again, these are objects, not single integer values. These are objects. The object is composed of, the way I've written it here, 4 integer values, x, y, z, and d as attributes, plus a method. So you're passing in, if you had an object with 10 attributes, you're passing in all 10 of those values. It's not a single value.
Okay, I think I'm getting confused with comparing what's getting passed in and what it returns.
What's getting passed in is the actual object itself, which is a whole big memory space full of data.
Okay, so in this example, that would be X, Y, Z, and D.
Yes. Right.
So when you say compare, so when you say compare object 1, object 2, you're going to compare X, Y, Z, and D. Okay, thank you.
Well, we don't know what we're comparing because we haven't written it, but exactly. X, Y, Z, and D are available for the method to use. Let's put it that way, whether we use them or not. Yeah.
Okay, I think I was getting confused with like if it compares what it's returning or what. So it compares what it's actually made up of, which are those 4 values that we've given the object.
Right. And also, it sounds like there's a slight confusion, so let's try to tease that out. Class A doesn't return anything. Inside of class A, there is a method foo that returns something. It returns an integer value, but class A doesn't do that. If you call foo, foo specifically is the thing that will return an integer value, but class A is just attributes and methods, a collection of values and a collection of methods. One of those methods happens to return an integer value. Class A doesn't return anything.
Oh, okay, thank you.
The methods inside the class may return something, but it doesn't make sense to say a class returns something.
So you'd have to call in that specific method inside
Exactly.
to get. Okay.
Like we did down here. Yeah, these are good questions. I like this stuff. Keep them coming.
Okay.
Down there. That's saying run that specific method. Okay.
And in order to run that method, you have to create that object.
That's correct. Yep.
Okay, thank you.
Yep. Okay, now I'm going to do, and forget that not everything's there. I want to run the compare method using object 1 and object 2. Does it make sense? Can it work? In terms of doing, in terms of what the signature says it needs, did I give it what it needs? What does the signature for the compare method say that it needs as input?
Just needs 2 A objects.
Right. 2 objects of class A. That's exactly right. And now the way I've written these lines of code, have I provided it with 2 objects of class A? Object 1 and object 2.
Yes.
Yes. Hold on, I'm doing a Zoom has this great feature where it keeps, if you don't do this exactly right, you can't open the chat box. There we go. Yes. Now, what if I did that? Have I broken the rule, or have I still maintained the rule? Am I still giving the compare method 2 objects of type A? Even though it says object 1 is of class B, object 2 is of class C, am I allowed to do that first of all? And if I am, does the compare method still work okay?
You're allowed to do that, but would it give you back wrong results?
Okay, so first of all, the first question is, or the first answer is I'm allowed to do that. That was the first question. And yes, I am allowed to do that. And then when I try to do this, do I run into any errors or problems?
No.
I'm sorry, I didn't catch who was speaking. You thought we might get wrong results.
No, but because they're from, you might be getting back different results from those 2 classes with the double compare might return a wrong result from what you're looking for.
Okay. The way I code, I can always get the wrong result. Yeah. No, this is actually perfectly fine. Remember, what did I call the inheritance relationship again? What's its informal term? ISA. It's an ISA relationship. A submarine is a ship. A tanker is a ship. ISA. So if I define my methods to work at the generic level, this actually works fine. So first of all, why am I allowed to do this? I said, hey, I've got I want to build something of class A. I'm going to call it object 1 and give me a new class B, which doesn't sound right, does it? Because I said, I'm going to get a new thing of class A, build me a class B. That actually works. Why? Because B is a A, right? The children are always versions of the parent. So if we wanted to do the airplane model, A is generic airplane, B is Cessna 172, generic airplane, my airplane equals new Cessna 172. That works out just fine because a Cessna is an airplane.
Would it be okay to say B object 1 equals new B? Because that's just how I was thinking to code it. But I know the A works. But is A better practice? I guess is my question.
And the answer is we don't know because it's going to be specific to what you're doing. But I'm going to show you why A can help you sometimes. So you're right. You could do this, and there's nothing wrong with that. Okay, but here's the beauty of this. If I define my methods to work at the generic level, I can put any kind of kid in there I want, and it will work. So for example, here I did object 1 and object 2. Well, object 1 is of class B, object 2 is of class C. That's okay because B is an A and C is an A, right? So they're both versions of class A, so that's fine. But the beautiful thing is, if I wanted to build this generic method that needed these two objects, and I didn't have the notion of inheritance, I would have to build a version of compare for A, and a version of compare for B and B, and a version of compare for C and C, and a version of compare for A and B, and a version of compare for A and C. You see how tedious this is? But because B extends A, B is a, I can build this method at the higher level, the generic level, and it will work properly no matter what I put in there, A's, B's, or C's. Although, as someone pointed out earlier, we would rarely build an object of the generic class. So you're probably only going to have objects in the B and C class, but all your methods, if they were built, assuming built to accept A, will work. That's powerful. That's not just about being a lazy programmer, which by the, good programmers are lazy. It's not just about less work for you and being lazy. It's about less error handling. It's about code clarity. It's about building code that can be extended easily. I don't even know when I wrote this code that next year I need I needed a new class. I didn't even know that when I wrote this code. But guess what? Compare will work for objects D of class D, which didn't even exist yet because D extends A and I built it for A. So I'm sorry, I didn't catch you ask the question about, I wanted to build mine as B object 1 equals new B. Perfectly fine. Perfectly fine. And it depends on your application. But be aware that if you need to do work across, need to do some direct comparisons across different classes, you build some of these methods at the higher level, and they'll automatically work for the lower, for the extended classes. Okay, we're at time. We'll pick this up on Wednesday, and we'll talk about now. Okay, we've got all these tools. How do we start to think about actually designing the actual code?
Professor, do you have time for? I'm sorry, I didn't mean to interrupt you.
Time for questions? Sure.
It's very specific to me and my project this evening.
Okay.
So it can wait a second. I'm sorry, I didn't mean to interrupt you.
Don't apologize. Do you want to message me, or do you want?
I think it'll only take 30 seconds.
Okay. All right. I'll hang out then.
Okay, thank you.
Yep. I'm going to stop share. I'm going to stop recording.